Okay, now students, let us see about Boolean operators one by one, and we will see all the three Boolean operators, that is AND, OR and NOT, in detail along with their rules. First of all, we are starting with the first Boolean operator, that is AND, that means dot. Okay. Now, every Boolean operator has a set of rules. You need to understand those rules clearly so that you are able to draw its representation, that we will see in a while. Okay. Now, what is the rule of Boolean operator AND? Okay, first I will speak, then we will draw this something new, that is called truth table, so you will understand how these rules are actually working. First, let us see. Now, for Boolean operator AND, we may pass X number of inputs. Okay, we can take 2 inputs, we can take 3 inputs, and so on. Now, if all inputs are on, if all inputs are 1, then only the output will be 1. Okay, suppose for example I am taking 2 Boolean inputs A and B, and I want A dot B. Correct? Just for them. I am taking something like this. Okay, now let us read the rule. If all inputs are 1, then only output is 1. This is one input, this is one input, this is the output. What is output? A dot B. If all inputs are 1, then only output is 1, otherwise output is 0. Let us see. Are all inputs 1? No, output is 0. Are all inputs 1? Yes, output is 1. Are all inputs 1? No, output is 0. We can take one more. Are all inputs 1? No, output is 0. So this is how this AND operator actually works. I hope you will be very clear with the example that I have given. So I repeat once more. An AND operator works in a case that it can take X number of inputs. Now, if all inputs are on, if all inputs are high, if all inputs are 1, then only output is 1, otherwise output is 0. Okay. Now, whenever we are going to talk about this AND operator and OR operator and NOT operator, we have to represent the inputs and outputs in tabular format or in the form of a table. I would repeat once more. Whenever we are dealing with AND, OR NOT operators, we have to note down the inputs and decide the output in the form of a tabular representation or in the form of a table. This tabular representation is called truth table. Okay. Why truth table? It verifies the inputs and processes the output and gives us the output in such a manner. Okay. Now, remember this pointer very well. Suppose we are dealing with 2 variable input. Suppose we are dealing with 3 variable input. Okay. First we have to decide how many entries have to be there in a truth table. So, for that, there is a formula 2 to the power n. What is n? N represents number of inputs. Okay, you will understand this once. Okay, let me draw a truth table for AND operator with input of 2 variables. Suppose those variables are X and Y. What is my output? My output is going to be X dot Y, X and Y, because I am dealing with AND operator. Okay, so pay attention. How many inputs are there, students? 2. Okay, X and Y. How do we decide how many entries are necessary here? We will use this formula 2 to the power n. What is n? N is number of inputs. How many inputs do we have in this? 2. So 2 square will be 4. So students, in this truth table of 2 inputs, how many entries have to be there? Entries will be 4. Okay. Now, we are, you can say, following a specific pattern of entries so that you do not make any mistake. We will follow this pattern, that is easy to remember. So how many entries will be there? 4. Let us start. And what will be the entries? Predominantly 0 and 1. Let us start. 0, 0, 1, 1. Correct? 0, 1, 0, 1. Okay. So how did we write? We did not write any random numbers. We followed a pattern. 0, 0, 1, 1, 0, 1, 0, 1. Now nextly we will do the truth table for 3 variables. Then you will be more clear how this thing is actually working. Okay, so can we find out the result? Remember the rule? all bits high, then only answer is high, then only answer is 1. If any bit is not high, the answer will be 0. Are all inputs 1? No, answer is 0. Are all inputs 1? No, answer is 0. Are all inputs 1? No, answer is 0. Are all inputs 1? Yes, answer is 1. Okay, so I hope you are able to understand how this truth table of AND operator for 2 inputs actually works. Okay, now we will be dealing with 3 inputs. Okay, so just learn the pattern that I am doing. Now 3 inputs mean 2 cube. 3 inputs are there, so 2 cubes. So how many entries are there? 8. Correct? Let us see how we are doing. So 3 inputs we will introduce. Suppose I will introduce one more, z, and the answer will be x dot y dot z. Okay? So let us start carefully. 8 inputs. Okay? 0, 0, 0, 0, 1, 1, 1, 1. Correct? 0, 0, 1, 1, 0, 0, 1, 1. Okay? 0, 1, 0, 1, 0, 1, 0, 1. So I hope you are very clear with the pattern. For 2 inputs, what did we do? 0, 0, 1, 1, 0, 1, 0, 1. For 3 inputs, what we are doing? 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, and so on. Okay, so let us check carefully. Are all inputs high? No, answer is 0. Are all inputs high? No, answer is 0. All are high? No, answer is 0. All are high? I think we have to check this properly. This 0 is not written properly in the case. Okay, are all are high? No, answer is 0. Are all high? No, no, no. Final will be getting all are high, so that is yes. Okay, so this is how, students, a Boolean operator AND is actually working, and we have represented it in the form of a truth table. Also, what is a truth table? It is tabular representation of all inputs along with the outputs after processing. So this was AND Boolean operator. I repeat the rule. What is AND Boolean operator? It suggests dot, and final output is high only when all inputs are actually 1 or all inputs are high. You can pause this video, rewind this part. It is very easy to understand. Okay, now students, let us see the second Boolean operator, or that is plus. Remember what was there for AND, so that you do not confuse with the rule. What was the rule for AND? If all inputs are high, all inputs are 1, then only output is 1. Okay, so for final result for in AND to be high, we want all the inputs to be 1. Here there is a specifically different. Or plus, that is plus. If any input is high, final result will be high. If all inputs are 0, then only it will be off. Okay, let me write. Say A, B and A plus B. Okay, we will just see an example. Say 0, 0, 1, 1, 0, 1, 0, 1. Are all input, is any input high? No. Is any input high? Yes. Is any input high? Yes. Is any input high? Yes. Okay, so I hope you are understanding how this thing is actually working. What was there in AND operator? I repeat once more, do not confuse. If all inputs are high, then only output is high. What is there in OR operator? If any input is high, output will be higher. Output will be 0 when? Only when all inputs are 0. Okay. So again, let us see quickly the truth table for 2 variables. Say A, B we just saw, but formally we are seeing. Okay. How many variables are there? 2. So how many entries will be there? 2 square 4. 0, 0, 1, 1, 0, 1, 0, 1. Is any input high? No. Output is 0. Is any input high? Yes. Is any input high? Yes. And is any input high? Yes. So this is how the, you can say, OR operator for 2 variable actually works. Now we will see it for 3 variables, so that our understanding is more complete. Okay. So 3 variables, A plus B plus C. We will write it carefully this time. 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 1, 1, 0, 0, 1, 1. 0, 1, 0, 1, 0, 1 and 0, 1. Is any input high? No. Is any input high? Yes. Is any input high? Yes. Yes. I think yes, yes, yes and yes. Okay. So I think this is very easy to understand. This is how a OR operator works. OR operator will be having high input, high output if any of the inputs is actually higher. If all inputs are 0, then only output will be 0. Okay. So I hope you are clear with the second type of Boolean operator, that is OR. Okay students, so let us see the last topic of this video, that is the NOT operator. Now remember about the previous two operators, that is and OR. It was operating on multiple inputs. It was operating on 2 inputs, it was operating on 3 inputs, and if required it would be operating on 4 or more inputs. But the NOT operator will have one restriction, that is it will operate on only a single input. Okay, NOT operator is also said to be complement. Why it is called complement? Whenever any input is given the NOT operator, it will actually reverse the value. Reverse the value means if value is 0, it will change to 1. If value is 1, it will change to 0 and so on. Okay, so NOT operator will operate only on a single input. Let us see the small truth table for this. Suppose I have a single input called A. So its NOT operator can be either NOT of A, or we can also write it as A complement. Okay, so inputs will be 0 and 1. Okay, why 0 and 1? Because we are dealing with only one input, and what is the formula? 2 to the power n. So 2 to the power 1 will be 2 entries. So 2 entries are 0 and 1. So if A is given the input 0, what will be the complement of that? 1. If A is given the input of 1, what is the complement of that? 0. So I hope it is easy for you to understand this NOT operator. So in this video, we discussed about the introduction of Boolean logic. We discussed about the 3 important operators, AND, that is dot, OR, that is plus, and NOT, that is complement. I repeat the rules once more. In AND operator, the output will be high, the output will be 1 if all inputs are 1. In OR operator, the output will be high, the output will be 1 if any of the inputs are 1. And especially on the OR and AND operator can work on multiple inputs, that is 2 or more. Speciality about NOT operator is it is working only on a single input. It is also called complement. Whatever input is fed to it, it will actually reverse that, as you can see in the truth table. So that will be all from me for this video. In the next video, we will be seeing, you can say, numericals based on combination of all these 3 operators. Thank you and have a nice day.